Okay, just a reminder for the way I'm going to try to do things over the next few days is the warm-up will go with your 8th grade SC Ready standards to review or to teach something new, because sometimes it's going to be a new thing I haven't taught and sometimes it's going to be a review. And then during the meat of the lesson, we'll probably do a lesson on either something we still got to learn before the EOC or going back and reviewing a lesson for algebra. And then towards the end, we'll do some practice algebra questions. So this is a review for SC Ready, which is the 8th grade test, but this is also one of those standards that I told you that is a double standard in that it covers for 8th grade SC Ready and for Algebra 1 EOC. So this question could be on either test. So it says, consider the graph below. Part A, find the y-intercept and slope of the line. Fill in the blanks of this statement. So the easier part is the y-intercept. What is the y-intercept? 6, because what does y-intercept mean? Where it crosses the y-axis. And the letter that we use to represent y-intercept in the formula slope-intercept form is b, y equals mx plus b, where b is the y-intercept. And then slope. Before we figure out what the slope is, I want to ask you a question. Is the slope positive or is the slope negative? How do we know it's negative? Because it's going down from left to right. If it looks like somebody could ski downhill, it is a negative slope. If it looks like from left to right, you'd have to climb to get up it, it's a positive slope. So this is a negative slope. And then how do we find slope, Alex?
You take the y and x, whatever fraction is that's the fraction.
Okay, I think he's trying to say rise over run. You figure out how much it goes from 1 on the x-intercept up to how much it goes over for the y-intercept. Do you have to just use the x and y-intercept? No, you can use any 2 points on the line. So I'm going to go through and mark a few points as what I call bold points. So when I look right here at 6, of course, we've already figured out we have a bold point. At 1, 4, there's a bold point. At 2, 2, 3, 0, 4, negative 2. We have all of these. Just making sure they all go right through. All of those are what we would call bold points. So all you have to do is find any 2 bold points on the line. And then you have a couple options. You can use the slope formula. Can anybody remember what the slope formula is? No, that's slope-intercept form. The slope formula is y2 minus y1 over x2 minus x1. So if you have 2 points and you know the ordered pairs, you can use that formula. But if I have a picture of a graph, it's a lot easier to do what Alex said, to use rise over run, because you can just count how far up, how far over. So if we use the y-intercept and the x-intercept like Alex suggested, to go from the x-intercept to the y-intercept, how much does it go up? 6. And how much does it go left? 3. So what is 6 over 3? Negative 2. Because it's rise over run. You have to put the up and down over the left and right. So the y-intercept was 6 and the slope is negative 2. Before we move on to part B, does anybody need me to review the y-intercept or the slope? If they had just given us 2 written ordered pairs, we'd use this formula instead. But since it's on a graph and we can count, we can go up and over. If we had started right here, it would have gone up 2 over 1. And is it 2 over 1 still 2? Yes, so it doesn't matter which 2 points you use as long as they're 2 that fall on crosshairs. So the y-intercept was 6 and the slope of the line was negative 2. And then we turn to part B. It says determine the equation of the line, fill in the blanks to match the equation. They want this to be in slope-intercept form, y equals mx plus b. So in that first one, you're going to put y. What did we say the slope was? So this would be negative 2x plus what was the y-intercept? 6. Now this was a no calculator part, and SC Ready is going to have a no calculator part and a calculator part. The EOC is all calculator. So if they gave you this question on the EOC, you could type that into Desmos and make sure it looks like the same line we just had a picture of. Any questions? All right. If you would get out the comparing functions packet I gave you sometime last week, I don't remember exactly which day. This is what it looks like on the front. It's comparing linear, quadratic, and exponential. Later this week, we're going to have a test on exponential and comparing these three. So you'll have to graph, you'll have to be able to find the asymptote, you'll be able to find the y-intercept, you have to be able to look at an equation, tell them is it linear, quadratic, exponential. You have to be able to look at a table and tell me if it's linear, quadratic, or exponential. But today, we're going to look at something that it's a little more complicated. I don't want you to stress out about it. It will be a smaller portion of your test, not the huge portion of the test. But if you can do what we're doing today, you definitely can do the majority of what you'll need on the test. So we are going to page 14 in your packet. Page 14 in your packet. Page 14 in your packet. Now, at the top of this, it says linear versus exponential. So far, we've been comparing three, linear, quadratic, exponential. On these pages here, it's either going to be linear or exponential. We don't have to think about quadratic. But I might throw a little bit in there just to help you with some tips there. Also, I haven't forgotten about your flashcards. If you got any on Friday, I'll take them up in one bucket today so that I can sanitize them and let you get a new set. Or if you told me you didn't want to get a set over the weekend, that you want to get a set today, you can also, well, I'll have you grab those at the door. Yes. So looking at the top of the page, the way these couple pages work here is they're going to give you one out of all the sections, and you have to come up with the other. So let me explain what that means. Like on this one, they gave us a verbal description, and we have to come up with the missing boxes. On another page, they might give us this box, and we have to find the other missing pieces. So each time, you're going to have to find the missing pieces that are not filled in. So let's just read the description first. It says, I bought a vehicle for $15,000, and the depreciation of it was listed at 12.1% each year. What happens to the value of my vehicle over time? This is just a word problem. They don't want the answer yet, okay? The first thing we have to figure out is this linear or is this exponential? How do you know it's exponential? Okay, so he thought it looked similar to some of the exponential problems we did. Ashley? Because it has a percent. If something's changing by a percent, it's definitely exponential if it's changing by that same percent over time. The word depreciation is probably a hint there. In order to be linear, it has to be adding or subtracting the same number each time. If something's changing by a percent, it's actually multiplying by that percent each time. So this is exponential. So the first thing I'm just going to do right here is put exponential, because we have figured out, is it exponential or is it linear? So now I'm going to this first box, rate of change and initial amount. By how much is it changing each time? 12.1% is the rate of change. And what was the initial amount? 15,000. So now we've got to come up with an equation. If we know the initial amount and the rate of change, it's pretty easy to come up with the equation. The only thing is we got to figure out, is this a growth or is this a decay? A decay. So if it's a decay, we're going to use the formula with subtraction. So y equals the initial value. What is our initial value again? 15,000 times 1 minus, and we have to change our percent to a decimal, so 0.121 all to the x or t power. It doesn't matter which one you say. Now, if you were looking at multiple choice, it might not have that equation. It might go ahead and say 1 minus 0.121, which is 0.879. So it could look like this. You do not have to have both if it lets you open-ended answer it. But if it's multiple choice, it could be either one of these. And the only difference is the first one says 1 minus 0.121, whereas the second one, I've used my calculator to subtract those two numbers. But it's the same problem there. Then they want us to make a table. So there's a couple ways we can make a table. I'm going to show you the first way I want you to do it because I think sometimes we forget what a table is meant to be, but I'm also going to remind you how to do it in Desmos. And for ZOC, I want you to do it in Desmos just because it's faster, but I just want to make sure you remember where things come from in a table. So for a table, you would make an X and a Y, and you just insert some values. Since this is a real world situation, we do not want negative time. We don't want to know how much the car cost before he bought it, right? So we want to know when he bought it, that was time 0. How much did the car cost? $15,000. Your initial value is always your y-intercept. So if you've already figured out the initial value, you've already got a value for your table. If I want to know how much it costs after 1 year, how could I figure that out? Plug in 1 into the equation. So 15,000 times 0.879 to the first power. And I get 13,185. So after a year, it's almost depreciated $2,000.
That actually goes down forward.
To begin with. And then if we want to know the second year, how would we figure that out? Plug in 2. So same equation, just where I put the 1, we're going to make that a 2. And now it's 11,589. Let's just round it to the nearest dollar, $11,590. Because when you go to buy a car, you do not include change until you start figuring out tax with them. And let's just do one more point. I would plug in 3. Bless you. And it is $10,187. So in 3 years, it has dropped almost $5,000. And what do you think the last thing we have to do on this page is? Graph it. Now, they just want the first quadrant because honestly, in real world situations, all you kind of care about is the first quadrant because we are not worried about negative time. So we got to figure out what to count by on the y-axis. The y is the money. What do you think we should count by?
1,000?
Thousands or maybe 500s. Either way, 1,000 or 500. I don't care which one you did. It will be fine. I'm going to count by 500 so that every other one is 1,000. So this will be 500, and then I'm going to label this one 1,000. 1,500, 2,000. So I'm just labeling every other one by 1,000. 2,500, then 3,000. 3,500, 4,000. 4,500, 5,000. And I'm going to have to put 2 more tick marks just to get up to the 15,000. So I'll give you a moment to get that labeled. On the x-axis, I would probably count by ones because we're going by years, but they would kind of be scrunched up if I counted like. So is it okay with you if I skip every other one to count by ones so I can space them out a little bit? So to show you what I mean, the first one right here at the corner is 0. I'm not going to put a 1 at that one. I'm going to put a 1 at the second one. And then skip 1. So actually I'm counting by halves, but we're not going to label the half years. And I'm only going to count up to 5 because we're not interested in graphing this on and on and on and on forever. If you counted past 5, it would not be wrong. And then how do I graph it? Just plot the points, plot the X and Y. So at 0, 15,000, I put my first point. At 1, 13,185. That just means you just go a hair above 13,000. Not a lot, just a little bit. And when I get to 11,590, isn't every tick mark really $500? So I really need to go up when I get to this 11,000 right here. I actually need to go up to the 11,500 to put a little bit past it. And then 3 is at 10,187. It almost looks linear here, doesn't it? It almost looks like it's making a straight line. If we went down to 4, 5, 6, 7 years, it would start making more of that curve out. So this just goes to show you when you're looking at a very small portion of the graph, it's hard to see that it actually does curve out. But the graph would connect like this, and it is going to keep going down and over, curving, eventually getting close down to 0. Because can the car ever go below $0? No. So that's why that asymptote is going to be down there at 0. It could get close to being worth nothing, but it's never going to be worth a negative amount. Now, it might get to the point where you have to pay somebody to get rid of it for you, which is kind of like a negative amount. But any questions there? All right, take a moment, stand up, take a stretch break. I've been talking for a little while. I'll stop and switch the video, and then we'll go on to the next one.